We're going to have a talk about social network analysis and dashboard to handle social network data by Luca Mearelli. Luca works in the data science fields from quite a few years. Yeah, it's okay. So it's almost a newcomer in this field, and is going to present his work on a research project, I guess.
Yep.
Okay. Using Network X and stuff to visualize network data. So please welcome the speaker.
Hi. So I'm actually quite a polyglot programmer, and I have a confession to make, is that I've been coming back to Python at regular intervals since, I don't know, 15 years ago. I was developing with Zope for the web. Then I went back to Python a few years after that to use Amazon Web Services using Boto. And recently, since 1 year and a half, I've been starting to use Python more to do data science. I'm actually a beginner. I'm a little bit ashamed of my code that I'm going to show you today, but I hope you'll forgive me. No Python programmer has been armed to do this code, so that's it. I'm going to ask you for suggestions also about how to solve the things that you are doing. The work I'm going to present you has been done in one of the two main things that I'm doing right now. The first one, which is my main work occupation right now, is working on Measurance, which is a retail analytics software and service. We are actually turning physical stores into something which is handled like a Google Analytics web property. So you get your analytics about who's coming, who's going inside the physical store. But I'm going to talk to you today about the work we have done with Wikitalia. It's a research project, and it's a research project which is called a Catalyst. And it's in the field of collective intelligence. Well, collective intelligence is just a few words about it. It's this idea that when there is a group of people interacting freely and exchanging information online, then there is this ability of the group to exhibit knowledge which is bigger than the sum of the singular parts, than what every single person is able to know. And it's something which lives at the intersection of information systems and digital systems where people can interact among each other. As researchers Levi and Dekerkov say, it refers to the capacity of information and communication technologies to make people freely exchange ideas. And a second idea which comes often together collective intelligence is the idea of emergence. This is actually a natural science phenomenon. It happens when a great many number of entities interact with each other, and from their interactions a much larger scale phenomenon emerges. And we have examples of emergence everywhere in natural science, like in ant colonies, for instance, or the weather, clouds. Life itself, if we want to think about it, is the emergence of something from the molecules studied in chemistry, if you want. It's also important in social sciences and in economics to study the stock markets, for instance, or global crisis. And the problem with emergence is that the scale of the problem is much bigger than the scale of each single molecule or each single element which composes the great many items which are interacting. So it is very hard to do one thing. With emergent properties are very interesting, but it's very hard to be able to guide emerging environments toward the goal. And why it is important that it is hard? It is important because emergence can be very effective at solving big problems when, like online collaboration, for instance. We know that it works. We know that it works because, for instance, if we look at Wikipedia, Wikipedia is the biggest encyclopedia ever realized. And it exhibits very interesting properties like emergence because, for instance, it exhibits a high grade of coherence. But how do we explain it? How can we explain it? There are two things that we can use to explain it. And the first is the self-selection of people participating in Wikipedia. And the second is the social interaction among these people participating in Wikipedia. Self-selection means that each one of the people writing there is writing about the things that they care about. So they are interested in writing and contributing to whatever things they care about. And the social network inside Wikipedia is important because it means that this system, it favorites, it makes the relations between the people who are interested in the same topics, it makes them much easier. And it guides them towards collaborating. So this is an example, it's just an example, but it says us that this can work, this can make it work. And we have been interested in looking at online communities, even at a much smaller scale than Wikipedia, actually, because they have interesting properties. First of all, they usually exhibit emergence, which means that online communities can be enabled to build knowledge at a larger scale than a single individual which is participating. They also have two properties which are important for our task, which is to probably be able to guide emergence towards the goal. The first is that they exhibit strong design principles. By this I mean that the design of the online community is something which influences the way people are interacting inside the community. Think, for instance, at Stack Overflow. The design choices of Stack Overflow have meant that people were pushed towards collaborating and answering and selecting the best answers for each question. And they are also hackable. So it means that the community moderators can ideally change and tweak the properties, the interaction properties of the communities, and such as they could, for instance, guide the community toward the goal. So this is important. And the dream is to be able to build a community system where there is a feedback loop between the community users, the moderators, and the design of the community itself. This is a big goal, but we are starting at a much smaller scale. Actually, by we I mean the people working on this research project. Okay, we thought about a blueprint to follow to help what I just said is, and the blueprint is this. We take the community, we map the community onto a social network, which means we extract the social interactions inside the community. We measure the structural properties of the community, and these are important because the idea is that using the science of networks, we are able to make some interesting properties emerge from the community. For instance, the structural properties of the network could tell us if there is a specialization emerging in the community, which means if there are the subset of users which are specializing on some topics. They could tell us if there is resilience inside the community. Resilience is this idea that a network could still survive and thrive even if some of the nodes are removed. So if a moderator, which is very important in a community, goes away, or if a subset of users go away, then what happens to the community? If the community is resilient, if the network is resilient, then it's possible for the community to survive. We can think about balkanization, which means if there are different groups which isolate themselves one from the other. So all these properties are measurable in terms of social network analytics metrics. So we measure the structure properties, and then we visualize the structure of these metrics and the structure of the network. Then this enables the user, in particular the moderators, to tweak the interaction. So that means to change the interaction somehow and have the feedback loop close and see what happens. So what we built is a tool to visualize the network and do exactly that. So build a network from the raw data from the community, calculate the metrics, visualize them, and provide a feedback loop for the users. So actually, our first instantiation of the tool is geared towards small communities built around Drupal sites. We have done this because we have found that this is the most common software which is used for online communities in the sectors that we are interested in. But this also means that we had to make some tough choices, especially to make some tough choices around the tools that we want to be able to use. So we couldn't choose anything fancy like Hadoop or other NumPy or things which could lend us to analyze very big communities. So we had to make the choice to choose the very minimal things that we could use to enable the tool we are building. So the architecture is like this. At the basis of everything, there are source files, usually JSON files extracted from the platform, from the Drupal installation. And then we have a layer of Python scripts. Why Python? Because Python has NetworkX, which is a wonderful, wonderful library to do network analytics. It works very well at the size of networks that we have. Probably wouldn't be feasible for very bigger networks, but currently that's not the point where we are having eventual difficulties. It's more in the interaction side of things. The Python scripts take the source files, interpret them, and they output some other JSON files in a standard format, which we have devised, which drive the dashboard, which is a single-page HTML5 and JavaScript application. I really like the presentation before mine about Bokeh, because I think I could be able to do much of the same things in Bokeh, and I want to try it out and see how it goes. But at the moment, it's much more simple than that. So the backend is basically Python with NetworkX. The parsing pipeline, as I call it, is built like this. It parses source files. I said we started with Drupal websites, but we've gone beyond that with analyzing networks from Twitter hashtags or mailing lists or other source files. So parsing. There are different scripts which are able to parse these different formats, building a unified network from the interactions. We extract the metrics and we export the network and the metrics in a JSON format. So this is more or less what it does, the parse and compute pipeline. It loads all the files, it extracts some normalized data. We'll look at them in a moment at what does everything that, what does it mean? We take some metadata which we use for driving the visualization, like, for instance, the timestamp of when the data has been generated. And then we extract the edges. And then we do other things like extracting the nodes which are not active inside the network, and so on and so forth. We calculate the metrics and write it. So how do we build the network? It's a social network. What does it mean? Social network means that it's a network of people. So each person's interactive inside the community is a node. What it is, a link. A link is any interaction, any relevant interaction between two people inside the community. In the case of Drupal communities, comments are links. So if Bob comments on something that Alice has written, then there is a link from Bob to Alice. The opposite is true, actually. And then this means that I could have many edges between the same two people. So I could have many edges between from Alice to Bob, and many edges from Bob to Alice. For the purpose of showing the network in the page, we are aggregating all the links from A to B and all the links from B to A into one and only one edge. And this is also used to calculate some of the metrics. And sometimes we also reduce the network from a directed network. A directed network is a network where the edge between two nodes has a direction. So it goes from A to B. And A to B is different from B to A. Some of the metrics which we are calculating are metrics which are not, which need a network which is not directed. So how do we do? We construct the network taking the nodes from all the users. We filter, we take the user data. Sometimes we have the name, sometimes we don't have the name. We take the timestamp of creation. We'll see why it is important. We have an idea of when someone is a member of a team. Being a member of a team means that the person is already known to be a moderator of the network. This is important because one of the things that we want to show is the effect of having moderators inside the network. So what does it mean? What does it happen if I remove the moderators from the network? This is important. We extract the edges. So we use the comments. As I said, a comment is valid if it has both a recipient and an author. We do some cleanup of the data, and we build the links by having a map which has source and target elements and timestamps. And then we use NetworkX to build the network. So NetworkX has different kinds of graphs. As I said, the basic one is the multi-directed graph, which means that it's a graph where each two nodes can have many edges between them, and the edges are directed from one to the other. It has also a directed graph. This kind of graph is the graph in which the edges from A to B have been all collapsed into one. And from a directed graph, we can get with just one instruction the undirected graph, which means there is no difference between an edge from A to B and from B to A. So I want to go a little bit faster here. NetworkX has methods to add nodes and add edges to the network. We can add attributes to the edges. So the edges can have attributes which are useful to calculate metrics afterwards. We'll see how it does. And we do a few things here, like extracting properties or counting things. We are using, for instance, we could use, in principle, the count, the number of edges between two nodes, or the effort of the node to mean that the node is, a link is more important than another link. This is all interesting in the metrics. And then we calculate the metrics. We calculate both content metrics, meaning metrics which are referred to, for instance, number of users, number of connections, and number of community contributions, and things which are taken from the raw data. And these are interesting in the case of Drupal communities because it's an information which isn't readily available from the website. And then we have network metrics. All these metrics are very precisely defined in network science, and they have a meaning and can suggest things about the network. So let me show you a couple of examples here. The degree of a node. The degree of a node is the number of inbound or outbound links that pass through a node. So a node with a high degree means that it has a lot of edges coming in and going out. Network X has actually very simple instructions to very simple functions to extract the in degree, the out degree, or the sum of the two, which is the generic degree. We could pass also a weight attribute, means that the degree is weighted. That is, the degree of the network is not exactly the number of the links, but it's the sum of the value of the effort attribute of the links. So it gives us a way to customize the metrics easily. Another important metric from the network is the distance, which means that the distance of two nodes is the average number of nodes which have to be traversed to go from a randomly chosen node to another. It's a property of the network. It's not a property of a single node. Okay. If there is a low distance, that means that the information can spread across the network more easily. Because actually, it's said that there are 6 degrees of separation among any two individuals in the world. Well, some of the networks which I'm going to show you have 3 degrees of separations. So that means that they are very much more connected than the average case in the human population. So there is the centrality. Centrality is an indicator which tells us which are the most important nodes in the network. The centrality is the definition, the precise definition of the betweenness centrality which we are using is that it is the number of the shortest paths from all vertices to all others that pass through a node. So the higher a centrality of a node, it's a property of a node, the higher a centrality of a node, the more information is flowing through that node in the network. That means that a person is somehow someone who passes information around a lot. So then there is the modularity. Modularity is interesting because it gives us a measure of how much the network is partitioned into groups. It's a value which is a value available for the whole network. So we could say that a network has a modularity. It measures the difference between the network at hand and a random network of the same with the same degree distribution. Network science says that network modularity above 0.4 is very high, which means that the network has developed subcommunities. So we'll see. And subcommunities are defined as partitions of the network where the members are more connected to each other than to the others. So I'm jumping ahead a little bit. I'll put everything on somewhere online after. We export a JSON format. And we have a front end which is built as a single page application. It uses two pieces of JavaScript, v3.js for some of the graphs, and Sigma.js for the network display. Why we did this? v3.js is driving SVG. And at a large number of nodes, SVG is not feasible. It's very slow. While Sigma.js, it's a library specifically built to draw networks on the screen. It uses both WebGL and Canvas. It uses a lot of techniques to make the display very fluid. So, a little demo. So this is EdgeSense. This is a community which has been gathered around discussing about Matera 2019. It's the community of the people who have participated into the project which brought the European City of Culture 2019 in Matera. And as you can see, this is a representation of the network. The nodes are colored by the sub-community which has been identified by the algorithm. So we could switch off communities like this or show them. This helps a lot the moderators of the community, could help them, because it helps identify sub-communities which are talking more to each other. And it helps them because it's really a visual way to identify people which have specialized on something. The black nodes you see here, those are the moderators. As you can imagine, this is a very compact network. It has a lot of connections. We'll see another which has even more. And if we could do things like moving the network around and highlighting just a part of the network. Okay, to see we see the in degree, out degree, betweenness, centrality of the node. They're all people interacting. And we can even switch off the moderators. So this is the network without moderators. Everything goes, and looks like there are a lot of islands there. But there is a very large amount of people still talking to each other. And one thing that few of the people managing communities have told us is that one thing which is important is to know when someone is becoming important enough to be promoted to be a moderator. Okay? So this can show them, because they can switch off the moderators and see what happens. And we can go also back in time. And there it is. Let me see if I can show you. So that is the network. I cannot show you. Usually it's on the side, but with this size of the screen, we see the graphs. So this one above is Sigma.js. These at the bottom are D3.js. Okay. So let's see a different network. So this is Joyriders. It's an online community which has some peculiar characteristics. One is that a central tenet of this for the moderator is that no user should be left behind. That means that the first thing that each moderator has to do when a new user comes in is to go there and welcome the user and invite them to interact with the other. So we see that the moderators are very central to the community. So it's true that they are very central, but the fact that they are actively engaging the users and letting them know each other means that nonetheless there are interactions which are happening without the moderators, and there are a lot of them. Another example. So this is Innovatori PA. Innovatori PA is a community of people working in the public administration, especially around innovation projects. What is the characteristic of this network? Look at it and try to tell me. How is this different from this other? There are this kind of island growing like flowers around the moderator. Yeah, that's correct. Why does it happen?
Have you said public organization? What was that?
Call it Innovatori PA.
Well, I assume that the organization that is behind it is constructed from I don't know, submodules or modules of people that interact with each other, and there are districts, let's say, of people.
Yeah, almost there. It's a community which is very large. In fact, it's one of the largest probably which we have data on. It's 11,000 users, of which only 640 are active. And it means that why it's like this. It's like this because it's built around projects. So regularly, during the years, there is these projects around some specific topic where the moderator just writes one single message, the post which gives birth to the discussion, and then goes off. And the community so is built around one post or a few posts from the moderator, and all the other people interacting, replying to the moderator, and only to the moderator. So this is an artifact of the way moderation is done inside the community. Very interesting. So these are this is from a mailing list. Oh, this is interesting. This is the network taken from the Pythonit mailing list. This is an example of another way to ingest data. We take the dumps from the archives from the mailing list, we interpret it. It's a little bit more difficult to use mailing list data because at times there are changes in the way the mailing list, the names, for instance, of the people are recorded into the archives. So sometimes it may happen that the same people, if they have used two different aliases in the mailing list, appear in a different place. If they have used different email addresses, for instance. We can look at someone here. Let's see. Oh, is this? So you see, it's kind of interesting looking at how this goes. Last example. Oh, this one is taken from a Twitter storm, like all the tweets about this hashtag, which was related to one of the other communities. It's related to the Edge Riders, to a meeting that the Edge Riders community has done. But this is from Twitter, and you see people replying to each other using, citing each other, and like in a big ball of things. And this has about 6,000 users. It has an average distance of 4.3, which is high for this kind of community. It has a modularity of 0.7, which means that there are a lot of communities. If you look here, there are a lot of communities, which means that there are a lot of groups talking to each other. Okay, demo is finished, actually. So I'm going to rush through this. Sigma.js, we saw, uses a force atlas layout, various things. You have seen the dashboards, metrics, the filters I've shown you, the extras. One important thing is that it's able to export a format, an XML format, which is called JXF, which is the de facto standard for exploratory data analysis of networks, because it's a format interpreted by Jeffy and Tulip, which are the two main tools used by network scientists. So it's a way to build in the network with our tool and giving the output networks to data scientists. And that's it. Thank you. By the way, it's open source, so everything index. I mean, it's open source, so if anyone wants to hack it and use it, and just do it.
Okay, thank you. Thank you for a nice talk. Any question?
Thank you. Did you try to include in your model like the strength of the link? Like maybe two people can have a strong relation or a weaker one?
Yeah, actually yes.
What's the difference?
You mean the difference in the
Difference in the analysis between these two? Like a 0-1 connection or a weighted one?
Well, we are calculating that using, for instance, the length of the comment. If you are just commenting to someone and say go, it's good. It has a low value. If you are commenting using a lot of words, it has a bigger value. This goes to calculate the weight of a link between two people. We are still not using the weight of the link in the visualization. It's calculated, but it's not used. There is, as you have seen, there is a lot to do yet on the visualization side of things, because there are a few networks, a lot of networks now that we have some users, which are harder to understand without some more advanced, graph visualization. We are looking at different ways. Usually when there is a ratio of 1 to 4 between edges and nodes, up to 1 edge for node, 1 node for edges, it's possible to use these force layouts. Above that, it's kind of harder to use. We need different ways to represent the network.
consider only the length of the comment, then you miss the time information, right?
You miss the?
If you for considering the for example thickness or the level of interaction, you use the length of the comment as the weightage, right? As you use, I mean, number of.
we are calculating the weight of the link also.
But by you doing this, you miss the time information, right? For example, two points which are they can interact for many times, but with smaller comments. So if you wait
Actually, yeah. I mean, we calculate that, and when we use the length of the comment and we reduce the network, the multi-directed network, to a network which has only a single edge between two nodes, then we do the sum of the weight of all the nodes. So we take into account great many interactions in that way. But it's, as I said, it's not used in the visualization, so it kind of work in progress.
When you do the calculation about the length of all the comments, do you remove the quotes? Because, for example, you can quote some comment from another user, just saying, okay, whatever it is.
We do that. We do that in Drupal. For Drupal, for the mailing list, we discard completely the content because we weren't using the content at all to do the visualization. So we discard completely the content in the case of the mailing list, where this is more. There are more problems with replies, with long replies. In the case of the comments inside the platform like Drupal, there is less that problem because the comment is just whatever they have written.
So time is over. So thank you very much for your talk.
Thank you.